IT modernization has been something that's taken different forms over different periods. And the reality is often you hear, as it relates to major trends, that these are things that we've seen before or heard of before, or frankly are things that come out. So for instance, with cloud, people make the assumption that cloud is really software as a service or outsourcing potentially, just in a new form. And even technologies like we're going to talk about today with virtualization, virtualization is essentially not a new technology, and it's not something that is burst on the scene. It was an innovation clear on the x86 platform, but it's really been part of the vernacular in IT for a long time. And why does it suddenly create the compelling case today for allowing this new dynamism that we're talking about? Because when you really think about, and I think those of a generation who hate sort of hearing that we often have things come and go, that things start long ago and we just give them a new flavor. Virtualization is a concept that's been around since the mainframe and mini computer, and we did have a lot of optimization in that world, where we were able to address large memory blocks. We were able to get highly efficient storage that's direct attached. That was a model that was very optimized. As much as it was monolithic and maybe didn't meet the need, it frankly offered a very optimized, where you could run many applications concurrently and have them be isolated and all the benefits. And the question is why did we move away from that, and why are we sort of back where we are today? And the reality is as we started, all of us started to build really the networks and the infrastructures that we have today, there was an operating system that came along that fundamentally changed the way IT was architected, and that was Windows NT. Windows NT was a low-cost operating system. It ran on low-cost hardware, and the idea was, it's pretty inexpensive. We can buy a lot of infrastructure, memory, those pieces. But however, the challenge was that those things, that often operations ran at the kernel. So everyone said, well, I'm not going to put multiple applications on a single server. I'm going to dedicate a server to run my Windows NT and applications. And so people said, well, hardware's cheap, we have an infinite amount of energy, that's cheap. Let's architect systems that are highly verticalized, from the IT delivery service to the IT applications, to the middleware, to the compute, the storage, that will have a really vertical stack to deliver IT. And I think that was highly tuned to that IT delivery that we know about. And so we took a very vertical approach. Now the challenge is, when you take a very vertical approach to IT delivery, it means you gain no efficiencies at the infrastructure. You've essentially traded off and said, I'm going to have pure visibility down the stack. I'm going to be able to run a high available environment. I'm going to be able to isolate, but I'm going to isolate physically, not isolate logically. And therefore, we end up with infrastructure that is highly underutilized. And so even as we've seen maturity in operating systems and other elements that really would cause us to be able to run multiple applications on servers, we still over-engineer infrastructure. Our infrastructure was over-engineered the way a civil engineer would build a bridge and over-engineer it, and we created these vertical silos. Often megatrends occur they require three things. They require the technology to be at a maturity level where it can have adoption. It requires that the economic model work. And so no one would argue that virtualization, the maturity, VMware developed on the x86, it's got 10 years of maturity. It is a mature platform. It's all the Fortune 500s and every agency. It is mature. The economic model is clearly there from an operations. But the last piece is the political will. Is do we have the political will to make the change? And this top bullet is, I guess, being referred around town as the memo, is Vivek Kundra's memo on to chief information officers. And I'll just read a little bit of that memo. The reported number of federal data centers grew from 432 in 1998 to more than 1,100 in 2009. The growth in redundant infrastructure investments is costly, inefficient, unsustainable, and has a significant impact on energy consumption. In 2006, federal servers and data centers consumed over 6 billion kilowatts of electricity, and without a fundamental shift in how we deploy technology, it could exceed 12 billion kilowatt hours by 2011. And so he goes on from there. And so essentially, the gauntlet has been laid. There's no question that the underutilized, the lack of reuse, the high cost of operating, we don't have an unlimited way forward around resource of both, you know, the IT community who operates it as well as the energy that it takes to consume. So we need a new way forward. And so I think what you're going to hear about today is this new horizontal, you know, way to look at infrastructure and the architecture and the tuning that still maintains a highly verticalized look through the stack in terms of manageability, that you still get the benefits of manageability from a vertical standpoint and the tuning of the horizontal.